Okay, for number 4, they say the line y equals a squared x, and the curve y equals x times b minus x squared. That's a cubic curve, by the way. They say where a is a positive number, greater than 0, and a is less than b, so b is also a positive number. They say they intersect at the origin and at points P and Q. The x-coordinate of P is less than the x-coordinate of Q. Find the coordinates of P and Q and sketch the line and the curve on the same axes. All right, I'll do this one, and then we'll start moving through this over here. And again, one step at a time, so to speak. So we'll go to the whiteboard. We're on number 4. And I'm going to read it again. There's a line. And that line is y equals a squared x. And there's a cubic problem. And that cubic is y equals x b minus x squared, where they go on to say that a is a positive number and a is less than b. So I'm going to say I could probably graph this thing out. I'm just reading it at this point. And the line's pretty simple, by the way. It goes through the origin. And that goes on forever. So that would be y equals a squared x. And I want to do the other graph too. I want to do this one over here. And this has an x-intercept at 0. And it's got a y-intercept. I'm sorry, another x-intercept at b. So b is a positive number. I'm just going to b's over here somewhere. All right, I got to keep reading this over here. So the line, the curve, they said they intersect at the origin, and I'm going to look at this thing over here and realize that, this is going to be a cubic function, so I know it goes down here. And then at b, it's actually a repeated root, so there's going to be something like behavior like this over here. All right, so I know that much. And I got to keep reading this over here. It says where it intersects at the origin and at points P and Q. All right, let me just keep reading. Find the coordinates of P and Q. Let's see, the x-coordinates of P and Q less than the x-coordinate of Q intersect at the origin and at points P and Q. The x-coordinates of P is less than the x-coordinate of Q. Find the coordinates of P and Q. That's going to be a little tough, isn't it? So I'm going to say over here that this thing goes up, comes back down, and then goes back up. All right? Let me just read that again. And it says that the coordinates of P, well, P is smaller than Q. So this is the point P, and this is the point Q. All right, I got to keep reading it though. It says find the coordinates of P and Q and sketch the line and the curve on the same axes. Well, I got a sketch over here. I'm not saying it's a terribly accurate one, but after reading it, I'm going to say I'm pretty convinced of that picture. Something like this over here. And this is a point over here. This point over here is, let's see, b comma 0. This point over here is 0, 0. I know the slope of this line over here, the slope of the line is just simply a squared. And I know I got a cubic. Cubics look like that. And I got something that looks like this over here. But I don't know P and Q. Right? So what I'm going to do is try to figure it out. And the way to do that, just set them equal to one another. So a squared x would have to be equal to x b minus x. Right? I know that happens at x equals 0, but I'm not worried about this point. I know there's an point of intersection where x equals 0, by the way. So let's do this. It's going to be a squared x equals, let's see what I get over there. Well, you know what I'll do? Make it a little bit easier on me. X is 0 is the solution to the problem over here. So what I'm going to do is I know the solution, so I'm going to say over here x is not equal to 0. And if it's not equal to 0, I would get a squared x equals x b minus x. And if x is not equal to 0, I can divide both sides by x. This might make it easier for me to do it, all right? So let's see if we can do that. What do you get? You get, again, x is not 0, so you get a squared is equal to b minus x. You know what? I forgot to put the square here. All right. So what do I know? I know two things. I know a could be equal to b minus x. If that were the case, a squared would equal b minus x squared. But a could also be equal to x minus b. All right? If you square those, you get the same thing. All right? So I'm going to write that down. And to do that, I'm really looking what the x is going to be equal to. So in one case, the x is going to be equal to, let's see, b minus a. Where am I getting that? Right over there. I added x to both sides. The other x is going to be equal to what? A plus b. All right? Now look at the picture. The q would have to have the bigger number, which is a plus b. We'll get the y value later, by the way. Now, this point over here is going to be b minus a. Let me go back up here and see. Yeah, that makes sense. B is bigger than a, so b minus a is a positive number. All right? Let's do this over here. What are you going to get? Well, the easy place for me to plug it in is the line. And that's going to be what if it's a plus b, you get a squared times a plus b. I'll write that down. So a squared times a plus b. That's the point there. What's the point q? It's going to be a squared, and then it's going to be b minus a. All right? And let me just make sure I've done the question. I don't think you need to multiply it out, but you can if you want. Let me just take a look at this one over here. So they asked for this. They asked for the sketch. We got that. And they asked for this. And I think we're okay. I think we're done with that one anyway. We'll go on to the next part of that question in a moment. Thank you.